Your earwax is either wet and sticky or dry and flaky, and which one you have comes down to a single letter of your DNA. The very same letter in the very same gene also decides whether your armpits can make body odor at all. One typo. Two of your body's strangest secrets. The gene is ABCC11 on chromosome 16. It builds a microscopic pump that sits inside your apocrine glands, the special sweat glands that line your ear canals, your armpits, and your breasts. At one position in that gene, people carry either a G or an A. That single base decides everything downstream. It was tracked down in 2006 by Koichiro Yoshiura, Norio Nikawa, and their team in Nagasaki, Japan. They scanned the genomes of more than 100 volunteers, some wet-eared, some dry, narrowing the signal to one stretch of chromosome 16, then to 37 candidate letters, and finally to a single one. It was the first time a single letter of DNA had been shown to control a visible, everyday human trait. Here's why one letter matters. The G version builds a working pump. The A version swaps one building block of the protein, and the broken pump never even finishes being made. The cell flags it as defective and shreds it before it ever reaches the gland. No pump, nothing gets secreted. So inherit two A's, one from each parent, and you get dry earwax. A single working G is enough for wet. It wins. And the pump's other job is your smell. Fresh sweat from these glands is completely odorless. The working pump loads it with invisible, scentless molecules, and then bacteria living on your skin take over, snipping those molecules into the pungent compounds we call body odor. The smell isn't really made by you. It's made by Staphylococcus hominis, feeding on what your pump puts out. Break the pump, and the bacteria get almost nothing to work with, and almost nothing to smell. So this gene doesn't just change your wax and your sweat, it changes who lives on you. A working pump feeds the odor-making staph. A broken one leaves the armpit to entirely different microbes. And deep in the ear canal, wet wax and dry wax ears grow measurably different communities of bacteria. Your genome writes the menu. Your microbiome shows up to eat. That one letter also draws a map. The dry earwax A first arose in Northeast Asia, perhaps 40,000 years ago. Today, it's carried by 80 to 95% of East Asians, and almost no one of European or African descent, where wet wax and body odor are nearly universal. It's why the deodorant aisle looks so different around the world, and why in Japan, strong body odor is a recognized medical condition, sometimes diagnosed in part by checking a person's earwax. One letter, a pump in 3 glands, a smell outsourced to bacteria, and a map of where your ancestors came from, all written in your earwax. The Gene Channel.